Hello and welcome to the JENEsys Edge VAV technical training. My name is Charles Johnson, lead trainer and technical engineer at Lynxspring. We're going to be talking about the entire process of the JENEsys Edge VAV. So the topics that we're going to be talking about today are the Edge VAV license, the spanning tree protocol, Onyx Rapid Integration Tool, continuous commissioning, and the minimum controllable flow. Let's talk about the JENEsys Edge VAV license. The JENEsys Edge VAV controller license ships with a fixed license that allows 3 devices and 50 points to be used in the controller. The 3 devices reference additional devices added to either of the RS-45 port connections as well as the Onyx network itself. So that 50-point license limit references all points in all 3 connected devices. So that's total, not per device. So these devices typically are Modbus and BACnet sensors that we're going to be using, such as like a Viconics VT8350. Now, if we're using 40 points of that, well, we have 2 devices left and 10 points available. So when you're doing integration like this on an Edge VAV, please be mindful of what you're bringing in to make sure that you don't go over that point limit, because we can't change it for you. Now, because this is a fixed license, it has a lifetime SMA, which means that you can upgrade this to whatever version of Niagara 4 that we offer with those Edge files for the lifetime of the controller. The SMA does not expire. Also, in addition to this, because it's a 50-point limit, it's under even the 100 points that would be required for an Edge Lite controller. So this actually will be an Edge Lite device, which means that you can have 10 of these per Niagara network connection. Now let's talk about the spanning tree protocol. So the spanning tree protocol is a protocol that's used to allow multiple physical paths between network devices without creating a broadcast storm. So this is done for redundancy. We leverage spanning tree protocol in the Edge VAV product line to create a loop from one port of the network switch to daisy chain a maximum of 25 controllers back to another port on the network switch. So this loop arrangement allows multiple paths between controllers and the network switch should one connection or controller fail. Spanning tree protocol is going to determine the fastest route to a controller and use that path until a faster path can be found, or if the device is no longer reachable by the quickest path. So if we look at this setting here, we can see that between these 4 devices, communication goes from VAV 101 to 102, and then from 104 to 103, but not in between 102 and 103. That's because the secondary port on the VAV 103 to the primary port of VAV 102 is blocked to prevent a broadcast storm. So if the network connection between the VAV 101 and 102 is disconnected for any reason, such as during renovation, or maybe the cable goes bad, well, then the network pathways are going to be reevaluated and an alternate pathway is going to be implemented. In our example, the alternate pathway to communicate to 102 passes from VAV 103. So that secondary port is going to be opening up again to allow the communication to pass, keeping all controllers online. Once that connection is fixed, then communication port will be blocked between 102 and 103 again. The network can support multiple loops on a network switch or span across several network switches. Just remember that distances between ports can't exceed 100 meters or approximately 328 feet. So you can see here in this particular figure that we have a network switch and we have the supervisor plugged into one, our air handler plugged into another port, and then we're using 2 ports per network loop, one being on the first floor and one being on the second floor. Now, let's talk about the Onyx Rapid Integration tool. So we're going to go over the entire overview of the implementation process. So the supervisor implementation process uses the Onyx Rapid Integration tool, and it falls into 5 different functions. A few of these functions are performed by the integrator, so that would be you, and then others are performed by the system itself, or what we say under the hood. The first thing that the integrator needs to do is that they're going to need to set the IP addresses for all the VAV edge controllers. The second thing they're going to be doing is they're going to prepare the spreadsheet with the VAV specification data and then use the Onyx Rapid Integration tool to import that data into the supervisor. So we're going to be using the Edge VAV configuration to build the spreadsheet. Then we're going to be using the Onyx Rapid Integration tool to import that spreadsheet. Then, as the system builds each discovered and imported VAV station, it's placed under a zone, which is then placed under a supply and air handler. This structure is built on the data based upon that spreadsheet. Then the Edge VAVs come with a factory default station name, whether it's VAV14 or Edge VAV underscore 02 underscore 01 underscore 18. It could be the station name. I actually don't know what comes out of the box. I've configured mine separately. Anyway, during the import process, you can select to rename the VAV controller station names based on that spreadsheet data. If you do, the system's going to rename the station and then it's going to reboot them. This was actually done in my demonstration of the Onyx Rapid Integration tool in an earlier video. Then we have several post-import tasks, such as configuring the universal inputs, copying logic folders, which are the BOG files, and connecting any post-install supervisor level links. Now we're going to be talking about setting the IP address of the VAV boxes themselves. The Edge VAV controller, the purpose of setting the IP address, 2 connections are used. The first one is the USB connection that is next to the primary port. This is actually a mini USB and not a micro. Again, a mini USB port will be required, which then the IP address is going to be 192.168.7.2. I actually recommend this really all the time, especially if you have these on on a test bench. But even then, out in the field, it's also pretty good just to connect it right there instead of the Cat5 cable. Or Cat6 Ethernet cable. Sorry, I'm kind of old school here. Then we have the primary port. This is used to connect via Ethernet. However, to determine the IP addresses is a little bit unique, other than like other edge devices or a JENEsys or a PC8000. The secondary IP port should not be used when connecting directly to a controller. It is disabled by default, and it's used primarily for daisy chaining. You can enable this port, but then again, you lose the daisy chain functionality, so we recommend that we don't enable it at all. However, let's talk about how we determine the default IP address of the JENEsys. It is not the last digit of the serial number of your VAV or the host ID. It's actually the last 6 digits. So it's going to be 192.xx.xx.xx, where the X's are the last 6 digits of the serial number of the VAV controller. So the serial number can be found on the back of the controller. And in this one here, for the example, it is going to be 192.51.0.80. So this is done with the intent of you can put a bunch of VAVs on a network together without having any kind of IP address, without having multiple or duplicate IP addresses. So each of them are unique. This is why I recommend connecting to the USB connection on the bottom of the VAV controller. Now, how do we set the IP addresses? Well, it's done through two ways, and we're used to doing them either way from our Niagara experience. We can do this either through the platform of the controller and going to platform and TCP/IP configuration, or we can go to the config space and expand the services container. And under the services container, there's the platform services folder where we have the TCP/IP service. Both of these are going to lead to the same outcome. We're going to go ahead and be able to set the IP address of the controller this way. Now, three things are required for the Edge VAV. While we always need an IP address and a subnet mask, we will always need a gateway, even if we don't use it. The gateway is 100% required for the Edge VAV controller. Now, one thing that we, that we always try to recommend is to make sure that you don't enable DHCP. If your customer wants DHCP, then you'll do something called a MAC address reservation. So this means that you will take the physical address of the port itself, and based upon this physical address, it will be assigned an IP address itself. So it's kind of a way of doing a static IP via dynamic setting. Now, once we have that set up, let's make sure the correct files are in place for the supervisor. So the 5 following modules must be installed onto the supervisor station before proceeding. And I say 5 because what if you are not using a Pro Builder workbench? Because the Edge system or the Edge product line is an open NIC, which means that you can use any branded workbench and it will work with our controllers. So the following modules are absolutely required: the Onyx driver runtime and workbench, the Plat Onyx runtime module, the Onyx ASC runtime and workbench modules, the Onyx VAV runtime and workbench, and the Lynx kit control runtime and workbench. You can grab all these from the resource website if you need it. And where do we put them? We put them in our modules folder of our Niagara directory, whether this is Pro Builder or a workbench that actually is the same type or the same revision number of our Edge files. So currently we accept 49U1, 410U4 as of this recording. 410U6 is in the works, and 411U2. We do not have 412 as of this recording. That was pulled from our website due to issues with the MSTP trunk. So we currently have only 411, 49, and 410. So those flavors. But again, you can obtain all these modules from the resources website. And after you download these files, place them in your workbench installation folder in the subfolder called modules. Now, we need to create a station for the supervisor. And this step requires a decision. Is the supervisor new or is it existing? And if it's existing, do we have the credentials to access the platform and station? If it's new, are we going to use the standard supervisor station that's provided by Lynxspring? Or are we going to create one from scratch or from our own template? So depending upon this decision, we're going to need to use one of the following scenarios. So if we have a new installation, all we need to do is use the platform station copier. That's because the standard station is already set up with the necessary files and folders that we need. The bottom line here is you want to make sure you use station copier only when there's a new installation. If we have a brand new supervisor station, we're going to be using the tools new station command. And then you're going to copy all the files from the template station into the folder structure of the new station. Or if we have an existing supervisor station, all we need to do then is to integrate the files into the file structure that is required. Now, the files that are needed for the supervisor contain a template folder, 5px graphics, and 3 BOG files. So the graphics and template folder are kept in the file folder. The BOG files are copied from the files folder to the supervisor station. The BOG files contain pre-built Niagara programming for quick and standard deployments. So the AHU logic BOG is copied to the supervisor after the initial AHU and RTU level configuration. The zone logic is then copied to the supervisor station after the initial zone level configuration. Then the VAV BOG file, which is actually the most important of those files. This is used during the discovery and station adding to the Niagara network to build the VAV supervisor stations. Without this process, or without this file, we're going to have to discover each station individually, discover each point individually, and create any supervisor level programming necessary. So the VAV BOG file is actually used to do that for us. Now, let's talk about the Edge VAV configuration tool. So new to version 2.1, the JENEsys Edge VAV configuration tool is a window-based application. Integrators can now use the tool to build their VAV configurations and export their data to a spreadsheet to import into the supervisor. Features of this tool include a template editor where you can save VAV configurations to a file and quickly add them to one or more VAVs during the VAV configuration. You can save projects to a file to access and edit later. You can start at the beginning, which specifies the number of VAVs and the number of air handlers and the names of the zones, and you're on your way. You can also use a number for the VAVs and specify that they're to be used for every zone. Doing this enables an ability that allows you to automatically build the navigation tree structure with one click. Using the naming structure section of the project setup screen is used to customize the names and of the AHUs and the VAVs. You can build the navigation structure, which is easy to use in a tree itself, which is actually right here in the project setup folder. And then in the VAV configuration entry screens, you can select to choose and edit more than one VAV at a time. So you can select multiple VAVs for bulk editing. And this also includes a validity check to make sure that your spreadsheet is error-free. And then you export the configuration with a touch of a button here in this Build XLS. Now, before we start the steps, let's go ahead and spend a few moments to talk about the process overview for the Onyx Rapid Integration tool. After the spreadsheet is ready, we're going to go ahead and import it into the supervisor. In the Onyx Rapid Integration service display, a Discover button will start the import process, and you'll have the option to set several options, for instance. Remember when we mentioned about the VAV BOG file was the most important BOG file that we copied to the supervisor station? So there's a chance, however slim, that there may be an updated release after we've copied this BOG file, but before we started the import. So in this case, we can choose to replace that critical file with one that's more up to date. Otherwise, we're going to go ahead and keep the existing VAV BOG file. Likewise, if we have more changes to a spreadsheet if we would need, then we would choose to either keep the existing spreadsheet or select a new one. The configuration process uses options that may require it to connect to the VAV controller stations. Due to this, it's going to ask you to provide the station credentials. Best practice here is to make sure that each VAV station has a common station user that can be used. Another option, that we discussed earlier was the ability to rename VAV controller stations. So if we select that option, which is highly probable, you're going to need to enter the VAV platform credentials. If we don't have access to these credentials, all station names will need to be performed individually. So it's really important to make sure that you have that. Once the import is complete, we're going to drag and drop one or more of those entries into the Discover pane, to the database pane. From there, a pop-up box is going to allow us to make any last-minute changes before the system starts the configuration process. This includes creating the folder-subfolder structure, creation of the supervisor stations, as well as writing the information. So we're going to be waiting for all that after it's done. And in the video I showed you, especially on a PC supervisor station, it actually doesn't take that long to do. So it's definitely not an all-day process and definitely saves you a significant amount of time. Now, before we move on, there are some possibilities that the configuration import or configuration database add job may result in more than one or more errors. So the first thing that upon discovery, if we leave any of the fields that would be considered the drop-down on the spreadsheet blank, it's going to fail that automatically. So that's if you actually are using the original spreadsheet with the drop-down fields. This doesn't necessarily apply in the configuration tool itself, but there are, if there are certain things that you did leave blank, it may fail. So, but any other kind of text or number entry fields blank, defaults are going to be added. The MAC address is going to go to all Fs. The subnet mask would go to all 255.255.255.0, or subnet 24, as some people may call it. The gateway will go to 192.168.1.1. The RTU IP address is going to be 127.0.0.1, and any number fields are going to be 0. Now, if you are seeing this error in the database add, more than likely the culprit is going to be that the supervisor name and the supervisor IP have been mismatched in the configuration tool. Something did not add, or something wasn't put into that spreadsheet. The other thing that the other common error that happens is people forget to put the Lynx kit control module in a non-pro builder workbench, which will also give you a could not invoke add. And you can find that error, especially if you go to the platform, you go to the application directory, you'll actually see that error there. So most importantly, we really don't recommend that you edit the VAV configuration spreadsheet itself, because it can result into one or more import or add errors for even more mistakes. This is why we created the tool in the first place. Without the tool, originally, we just had a spreadsheet for you to put all the entries in. However, to get that out of the way, the configuration tool was the easiest thing that we came up with to make sure that you don't edit that directly. Sometimes you still have to, but if you have different types of VAVs, like for example, FPB boxes and VAV boxes that are named FPB VAV or FPB01 VAV01, FPB2 VAV02, you can create two separate spreadsheets and import them at each part of the Onyx Rapid integration. You can do it twice and import the new, or you can then just copy all them and merge them all into one. Merging obviously has some risks, which is why we say we really don't want you to edit the configuration spreadsheet directly, but if you're careful enough, it can go off without a hitch. Now, also with the Onyx Rapid integration tool, a summary now of the VAV configurations will show up, and you can export that to an Excel copy for your as-built later on. Also, a summary page view is going to provide a table of each VAV supplied by an air handler. Points are then added to that summary as required to provide one screen look at the state of the AHU VAV system. So any VAVs that are under any of the zones for that air handler will be put on that graphic. And it's actually pretty sweet to see happen. As well as we give you the ability to add floor plan graphics from the Onyx Rapid Integration tool. It will create PX files for you, and then you drag and drop the floor plan onto that PX file, and then you drag the space temps that were added to that added to that PX file. You get to drag them around on the screen. And again, I have that in the demo of the Onyx Rapid Integration tool. Now we are going to talk about continuous commissioning. So the continuous commissioning feature, the continuous commissioning feature of the Edge VAV station it's an automated program. So pretty much what happens is that it's going to commission the VAV devices monthly, and each zone that's created on the supervisor is going to commission only its zone level controllers. So each VAV is going to have its own VAV system monitor graphic to monitor to the state of the commissioning operation. The graphic also contains a pop-up of the local VAV commissioning settings. And then as each VAV completes its commissioning, a report is going to be generated and sent to the supervisor. And each supervisor zone is going to have a commissioning manager to monitor the zone commissioning activities. The configuration settings for the zone commissioning manager involve providing the weekday and time by the hour for when the commissioning should start each month. So it's actually a trigger schedule that you're going to see in the station. So when the zone commissioning cycle is complete, each zone VAV commissioning report will be combined into a single zone commissioning report. So the continuous commissioning feature of the Edge VAV system provides customers with the means to ensure the ready operation of a critical air quality and control system. And its configuration has been simplified so that the implementation requires minimal effort. So now that we've just reviewed the basis for the continuous commissioning, this is just going to be a brief recap. So again, this is just an automated feature that commissions devices either for a schedule or manually. You can enable and disable continuous commissioning per zone. I like to do this during the summer. I will actually disable the continuous commissioning process during the summer because I don't necessarily want to turn on my electric heat. Some customers will not be very happy about that bill that they see. You also can set up for an automated configuration. So there's no need to, will do the whole thing automatically. When this happens, the supplying fan starts when needed. And then here you'll see the VAV system monitor. This is actually under the Edge VAV controller. If you go to the CX folder, which is under the drivers container. And here is the commissioning manager that is for a specific zone. And you'll see the VAVs underneath there as well as the state and the status of them. So continuous commissioning is managed per AHU zone, and configuring controls handled through the zone logic graphic. There are 4 control functions that are available. So one, we have a link to the zone commissioning manager, and this link takes you to a graphic that will allow you access to the commissioning reports. 2, a link to the commissioning zone schedule, and this takes you to the Niagara scheduling display where you can configure the zone continuous commissioning regular schedule. Then 3, you can right-click on this point to enable or disable the continuous commissioning feature. Like I said, this may be desirable during the month to avoid commissioning reheat VAVs. And then 4, you can right-click this point to manually start the commissioning cycle outside of its normal scheduled time. So this is particularly useful during installation and commissioning of the system to get a zone level report. Now, the VAV Commissioning Manager highlights, let's talk about access to the individual commissioning reports, which are hyperlinks that are attached to the VAV device under the name table. Then we have access to the full zone commissioning report using the zone report button under the configuration table. And then the last and next trigger shows the last date and time that it's going to run. The commissioning report for the information is going to be VAV name, type, commission date, start time, end time, And in the results tablet, or in the results table, you're going to see the subject of the test, the conditions that are going to be tested, the point names, the values. So what is the sampled value for measurement? For each test, a number of measurements are taken every 5 seconds. And if 12 continuous samples are taken without too much variance, the value is stored and presented here. Set point difference that you see is how far from set point it was from the measurement for the test. Red-green indicators talk about the success or failure of a test, and the elapsed is the amount of time that is required to start and complete a single test. One thing that to note for damper tests, the damper actuator must first pass a rotation check. If that fails, then no other commissioning tests are performed. For the heating coil, the cooling damper must be set to a minimum heating CFM. If that test fails, no tests for the heating are performed. Also, for the heating coil test, if it's a series or parallel fan, then what will happen is that the fan is started before any heating coil test. And the rows are filled with gray that represent fields that are not applicable. So next, we're going to go ahead and switch to the VAV controller to learn more about the VAV system monitor and its controller commissioning process. So let's talk about the VAV controller and the operation. So the first thing that happens is we're going to be doing an actuator rotation check. Once that passes, then the cooling damper is going to go open and close and check the 0 CFM airflow set point. It's also going to go through the minimum and maximum airflow set point. Once they pass, samples are gathered, and then it's going to check to see if heating is required. Then, if it's a hot deck damper, it's going to go through the same thing as far as minimum airflow. It's going to turn on the fan if need be. It will also do any heating coil checks, so 0%, 100%, or stages. Then the report is generated and sent to the supervisor. If it fails, the report is just going to show that it failed and send it automatically. Now, the VAV system monitor, again, if we double click on the CX folder, which is under the driver's container of the VAV station itself, it's going to bring up the system monitor. And so the upper section is divided into 6 sections, which show the general information of the commissioning process. It'll show the air handler mode for the commissioning process, the cooling flow, heating coil, hot deck heating airflow if there's a hot deck, and any auxiliary heat. Then we have the lower commissioning information, which is set to displays the commissioning state, which is idle and running, and of course the status, which means each step of the commissioning. Then it's going to show any various points that are an override that are required, and you can actually control all the points in the system monitor except for the state and status. If you left click on the gear, this will actually bring up a pop-up dialog box for the commissioning settings. So you use these commissioning settings to fine-tune the commissioning settings depending upon the unique VAV box parameters. So we have any delay settings, which are the damper delay, electric heat delay, analog heat, hot water valve, SCR. So the damper delay time is the time that the damper must reach a desired position or airflow to achieve the set point before failing the test. The electric heat time delay is to check the difference in discharge air temperature, so 5-minute delay. Analog heat, hot water valve, they're all the same, so it's going to be 5 minutes, 2 minutes, and 1 minute before it checks the difference in temperature. Then any cooling damper or hot deck damper thresholds here that you see. So this is the maximum percentage from position before we consider the damper to be at position. So that's the actuator feedback threshold. Then we take the percentage of the VAV CFM set point before we consider it to be at set point. And then, of course, it has to be steady for at least 60 seconds before we consider the test to be passed. Then for the heat coil settings, these are your threshold limits and time limits for the steady damper control, as well as the set point thresholds in which we need for the heating to increase, as well as the the discharge temperature to be at a steady level for a specific amount of time. And then, of course, in the sampling settings here, we talk about the number of samples, the limit. So it's actually 12 samples, and then the sample limiting time. Of course, it's 12 for the cooling CFM and the hot deck CFM and the discharge air temp, but the times are all still set to 5 minutes with the sample percent change at 1%. So it actually, this actually is the sample percent change before it actually resets resets to the collection. Now, let's talk about ASHRAE G36, the minimum controllable flow. So normally when I gave this presentation, I would normally tell you just go ahead, go to ASHRAE and download the white paper on it. But now since I'm doing this presentation here in a video, I'm going to go ahead and talk about what ASHRAE G36 actually talks about. So this is the minimum controllable flow in the JENEsys Edge VAV, and this is based around ASHRAE standard, I think it's 62.1, and California Title 24. So the minimum flow can vary from 1/100th of an inch to 15/100th of an inch water column, depending upon the VAV manufacturer. This allowing the CFM to go below this minimum controllable flow allows energy savings while protecting against overcooling when the zone requires less than the VAV control minimum flow. So this is actually called timed average ventilation. So what's going to happen is that's going to open and close the damper for 15 minutes and continue to maintain this kind of airflow. So when the airflow set point, which is either the cooling airflow or the hot deck airflow, when it drops below the minimum controllable flow value, the controlled flow set point is then overridden by a pulse signal that actually switches it from 0 to the minimum controllable flow. And you'll notice this appear on the VAV main detail graphic. So this pulse signal is based on a 15-minute cycle divided into an open time, which is a minimum, I think is like 1.5 minutes is what we set, and a close time. The open time is when the flow set point is set to the minimum controllable flow, and the close time for the flow set point is set to 0. So this cycle continues until normal set point rises above the minimum control value, and once you are now back into normal settings, it will actually disable this minimum controllable flow. So that's all I have for you today. I really hope that you enjoy this presentation, and I really do appreciate you checking out the entire video series. I hope that you enjoy them as much as I enjoyed making them. So thank you very much and have a great time.